4.4b, Proportion Applications. One important applications of proportions in the automotive industry is gear ratios. A ratio is just a comparison of two numbers. So as an example, say I had in a bowl, I'll draw a rudimentary bowl, say I had 2 oranges and 3 sugar cubes. The ratio of oranges to sugar cubes would be 2 to 3. It's a comparison of two numbers. So I have 2 oranges for every sugar cube in the bowl. So we can also write a ratio as a fraction. And this is where it comes into this is where proportions come into the equation. So we can write a 2 to 3 ratio as 2 over 3 in fraction form. So let's look at the first example. I have a drivetrain with a 2 to 1 gear ratio between the driven gear and the drive gear. So just two different gears. If the driven gear has 24 teeth, how many teeth does the drive gear have? So I have a 2 to 1 gear ratio, which means for every 2 teeth in the driven gear, I have 1 tooth in the drive gear. Well, how do I find out how many teeth the drive gear has? Well, all I have to do is set up a proportion equation with the corresponding components being in the same places. Well, what do I mean by this? So what does the 2 in the 2 to 1 gear ratio refer to? It refers to the driven gear because it comes first and we stated it first. So how much teeth does the driven gear have? The driven gear has 24 teeth. So 24 goes in the same place as the 2 in the fraction. What about the drive gear? Well, we have to find that. How many teeth does the drive gear have? We don't know. X. So as long as we correspond in our proportion application, the ratio number, the 2, with the number of that thing, the driven teeth, or the driven gear teeth, 24, and the 1 in the gear ratio with the unknown x, we should be good. Now we solve this like a normal proportion problem. So we multiply both sides by the LCM of the denominators. What's the LCM of 1 and x? It's just x, right? So if I multiply both sides by x, the x's cancel here, and this becomes 2 over 1, just 2x equals 24. If I divide both sides by 2, I'm left with, these cancel, and I'm left with x equals 12 teeth. So the drive gear has 12 teeth on it. Let's go to another example. If my driven gear has 34 teeth and my drive gear has 12 teeth, what is my gear ratio? So now we create a ratio from a fraction. So I want just like before, the driven gear comes first in the ratio. So my ratio is 34 to 12, or 34 over 12. Well, when we report fractions, we like to report them in most simplified form. So why don't I divide both of these by 2? And I end up with 17 over 6. So the ratio of driven gear to drive gear, the gear ratio, is 17 to 6.